Okay, so here's day one, and this was not quite 24 hours. So I don't know how controlled you want to call this experiment, but let's see what happened. So what I noticed was this little guy, he like curls up, so it was kind of hard to measure him. But my daughter was doing the starfish that came with this, and he also curled up, so I don't think it would have mattered. So we're going to look at how long this is now, what was the factor it increased by, so that we could figure out the percent it is of the original, and that's going to help us figure out what percent it increased by, because it is getting bigger. Okay, so here we go, and again I used my toothpick, so it looks to me like it's 9.9 centimeters, because you see there's a little bit of a, it's almost 10, but there's a little gap here because it wasn't quite closed. It was hard. I had to stretch it out with one hand, put the toothpick, and take a picture at the same time. No one was around to help me. They allegedly, my kids were doing their schoolwork, but we'll see, right? Okay, so I'm going to go with 9.9. Okay, so what factor did by what factor did the toy grow? So factor, that implies, let me get something you can see here. Maybe yellow will work. That implies multiplication, right? So we talked about this way long ago. We talked about unit rate, we talked about proportionality, we talked about direct variation, and then to do those, we talked about ratio tables. And last year in 6th grade, you did a lot of work with ratio tables. So when I ask what factor, I want to know, what do I multiply 7.2 by to get 9.9? And now I wrote a K, but I'm not going to leave it there, because I don't know if this is going to grow proportionately or not. So let me think about this. I guess we could use K, because for here, the length is going to grow this by a factor, and then the percent is going to grow by that same factor. So it is going to form a proportion. I'm just not sure if it'll be a constant rate of change. Okay. All right, so I guess I'll put a K there so we can remember that that's what the K is, the constant of proportionality. The rate of change, if we were to graph this, that's where we would see the slope. All right, so in order to figure out what I multiply 7.2 by to get 9.9, that's exactly why algebra was invented, right? So 7.2 times some number gives me 9.9. So to solve for K, I divide by 7.2. Now, if you're thinking, yeah, you divide, it's unit rate, perfect. I just don't go there, I go algebra right away. So either way, yes, you're finding the unit rate. My issue sometimes with unit rate is, which do I divide 7.2 by 9.9, or do I divide 9.9 by 7.2? I think we know it's division, but sometimes students and people in general do the division upside down. They do it wrong. So if I write an equation, I'm not going to get that wrong. So that's kind of why I do it. So this turns out to be 9.9 divided by 7.2 is 1.375, or 1 3/8. But of course I'm going to use a decimal. Okay, so that's my multiplier. So it got 1 375 thousandths, or 1 3/8 centimeters bigger. So what percent is it now? Well, it's the whole thing plus another 1.375, right? So in order for this to stay a ratio in this ratio table, I'm going to also multiply this by 1.375. So that is going to give me 137. Let me use a black writing tool in here so you can see. So 100 times 1.375 is 137.5. Okay, so it is 137.5% of the original. Okay, so let me write that somewhere. I think I can squish this table down a little bit. I can write on here. So let me write that sentence. The toy, or stingray, is now 137.5% of the original. Okay, so then how much did the percent increase? What is the percent of increase? Well, if I started at 100, my yellow again so you can see what I'm doing. I started at 100%, and now I'm at 137.5%. That's a difference of 37.5. So, let me squish again so I have room. So I'm going to say the percent, and it got bigger, so that's increase, right? So the percent of increase is 37.5%. Okay, so if I was going to kind of summarize, I would say this got more than 1/3 its size. Okay, so then I'm gonna go measure it. I think I have a day 2 measurement already. So I'm gonna go make you guys that slide and video, and then we'll do one more day and we'll see. I'll keep measuring it like over the weekend and whatnot to see like when it maxes out, if it doesn't by the time we're done, because I'm kind of curious about this. I've never done this, so like I said, I don't know how this is going to work out. So far so good. We got some good math down. Okay, so now that you see that, if you were kind of struggling with how to do this, remembering how the ratio tables work, and especially this is like our learning target, which I didn't give you because we're just kind of investigating. This is the whole purpose. We're trying to get an understanding of percent of increase, percent of decrease, and how that works. Okay, all right, I think we're done. Let's see, let's go to the slide. Okay, yeah, so the same one. I'm gonna post a picture, then I'll make the video like this. Please try to get that slide done though before you go ahead and watch the video, because like I said, we're not just trying to get a grade stamped on that. We're learning. I need to make sure you understand where this is coming from, and then next week we'll get notes and we'll practice and we'll get grades next week. Okay, alrighty.